All right, let's check this out and let's get these answers real quick. 58 grams of NaCl in 100 milliliters of water is a blank molar solution. Remember, molarity, or capital M, is just equal to moles over liters. That's it. So that's what we're going to be doing here. First, we have to find the moles of NaCl. So 58 NaCl is actually 1 mole. So this right here is 1 mole. And 1,000 milliliters, well, 1,000 milliliters is 1 liter. So if we want to find our molarity, it'll be 1 mole over 1 liter. So our answer is a 1 molar solution. 29 grams of salt in 100 or 1,000 milliliters of water is a blank molar solution. So 29 grams, that is exactly half of 58. So we know that this is 0.5 mole. It's still 1,000 milliliters, so that's still 1 liter. So it's going to be 0.5 over 1. So it's going to be a 0.5 molar solution. Let's look at this. 29 grams of NaCl in 500 milliliters of water. So this stays the same, so this is still 0.5 mole. 500 milliliters is half of a liter, so that's 0.5 liters. So it's going to be 0.5 divided by 0.5. Equals 1. So this is a 1 molar solution. Moving on down the line, here we go. 58 grams of NaCl in a 500 milliliters of water is, so remember 58 grams is 1 mole. And 500 is half of a liter. So 1 divided by 0.5 is actually going to give us 2 molar solution. Let's keep on going down the line. 58 grams in a 100 milliliter solution, so that's still 1 mole. This is 0.1 liter, so it's going to be 1 over 0.1. 1 divided by 0.1 gives us 10. This is a 10 molar solution right there. 58 grams of salt in 10,000 milliliters of water is a blank molar solution. So this is 1 mole. Now, 10,000, let's figure out how many liters that is. Say 10,000 divided by 1,000 equals 10. So the way you figure out how many liters there is you just divide by 1,000. So let me write it up here also and show you. 1,000 milliliters is equal to 1 liter, right? So if we want to know how many liters we have, we just divide by 1,000. So if we want to know how many liters 10,000 milliliters is, we divide by 1,000 and we get 10. So this is 10 liters. So 1 divided by 10 will give us 0.1 molar. This is a 0.1 molar solution. 14 grams of CaCl2, or calcium chloride, we already know that this is 1 liter, so I'll go ahead and write that down. In 1 liter of water is blank. So let's look up calcium chloride. Calcium's right here at 40, and chloride's right there with 70. So it's going to be 110. 110. So we want to figure out how many moles that is. So we're going to do 14 divided by 110. So 14 divided by 110. We get 0.127. We'll call that 0.13, but I'm going to keep it in my calculator like this. All right, just simply, we know what to do. We go 0.13 divided by 1, and that's going to be our molarity right there. 0.1, and we'll round it up to 0.13, right? Because it's just 0.13 divided by 1. Next question. Same amount, so we already know what that is, 0.13. This right here is 0.6 liters, so we're going to do 0.13 divided by 0.6. 0.13 divided by 0.6, 0.22. 0.22 molar. Let's keep on moving on. 0.056 grams of carbon dioxide dissolved in 10,000 milliliters of water is a blank molar solution. So let's figure out the moles of this. So 0.056 divided by, let's look at CO2, 12 plus 32. 12 plus 32 equals 44. 0.056 divided by 44, 0.0127. So we're going to call that 0.00127 dissolved in 10,000 milliliters. So I'm going to solve this one a little bit different than what I've been doing up here, but it's going to give you the same answer. And this is the way we actually solve it in class. So 0.00127 divided by 10,000 is equal to x over 1,000. All right. So I'm going to multiply this by 1,000. I'm going to divide by 10,000. All right. We're going to multiply up and then divide back down. And it's going to give us our x. And our x is equal to 0.000127. So we'll call that 0.00013 molar solution. All right, moving on. 0.00078 grams of F2 dissolved in 25,000 milliliters of water is a blank solution. So 0.078 divided by, what's the proper weight? Fluorine gas. It's going to be 38. All right, F2 is equal to 38. 0.00078 divided by 38 gives us this number right here. Call this, let's see, 0.000123421. Okay. Dissolved in 25,000, so we're going to divide this by 25,000 equal to x over 1,000. Multiplied by, I'm just going to multiply by 1,000 and then divide by 25,000. All right, and I'm actually going to put this into scientific notation. So let's see, I'm going to do scientific notation right here. What I'm going to do is I'm going to press second, then 5, or psi. It shows it to me in 8.21 times 10 to the negative 7. So I get 8.21 times 10 to the negative 7 molar solution right there. All right, last up, this is for honors right here. 3 liters of 0.71 calcium chloride are diluted with 800 milliliters of water. What's the molarity of the new diluted solution? Okay, so how do we start this off? We want to find how many moles of CaCl2 we have. So let's go we're going to do this 0.71. That's the molarity. Excuse me, let me erase this real quick. We're going to multiply this. Going to multiply this by the proper weight of CaCl2. And we already know this to be 110. We saw this earlier, so 110. That's equal to, let's do 0.71 times 110. It's equal to, I'm going to take off scientific. How do I do this? Okay, there we go. 0.71 times 110. 78.1. 78.1 grams. But since this is molarity, so 0.71 moles per liter, we're assuming by doing it this way, it'd be if there was only 1 liter. But since we have 3 liters, we need to multiply this by 3. You take this and multiply by 3, so 78.1 times. And we get 234.3. All right. So that's how many grams of CaCl2 we have. Now let's take this and find out how many moles we have. So 234.3 divided by 110, so that's the proper weight. Gives us 2.13 moles. And now we're just adding 800 milliliters of water to 3 liters already. Oh, sorry, excuse me, you guys couldn't see that. Okay, so 234.3 divided by 110 equals 2.13 moles. Okay, we're just dividing the weight of CaCl2, the weight of our calcium chloride, by the proper weight. We're going to get the moles. And now we want to figure out the diluted molarity. So we're just gonna add 800 milliliters to the already 3 liters that we already have. So that would actually just end up being 3.8 liters, right? So then we're going to do 2.13 divided by 3.8. That gives us our final molarity of 0.56 molarity. Rewatch if you have any questions.